Everyone, and thank you for attending today's webinar, Three-Phase Quad Microinverters, Why C&I Solar is Making the Switch. I'm Kelsey Misbrenner, editor with Solar Power World. Before we get started, there are a few things you should know. This webinar will be sent to all registrants so you can view it again. Slides and other helpful materials are available to view at any time via the resource window on your screen. Submit any questions related to this webinar in the Q&A window. We will try to answer these during the webinar, but if we don't get to your question, our presenter may reach out to you afterwards. And finally, if you're watching this on demand, you can still use all these features. Let's get started with today's webinar, Three-Phase Quad Microinverters, Why C&I Solar is Making the Switch. Today's speaker is Jason Higginson, Head of Marketing for APsystems. Today, we'll explore the potential of three-phase microinverters in optimizing C&I solar installations. And now I'll turn things over to Jason.
Thanks, Kelsey. Appreciate it. And thanks for having me. So we're going to talk about microinverters in C&I solar. It's a fun and exciting topic. I'm particularly excited about it. But really quick, I just wanted to give everyone a brief introduction on APsystems, just in case you're not familiar with who APsystems is and what we do. So APsystems was founded about 13 years ago in Silicon Valley, and we're one of the largest producers of module level power electronics in the world. We have 4 global business units. So in the US, we're actually based out of Austin, Texas, an R&D center in Cupertino. In Europe, we're in Amsterdam and Lyon, France. And in Latin America, we have our HQ there out of Guadalajara. And our APAC offices are in Shanghai and Jiaxing, as well as Sydney, Australia. So some key facts about APsystems. So we're a global leader in solar microinverters. We're also a global leader when it comes to multi-module microinverters, and that's microinverters that serve more than one PV module. We're number 1 when it comes to multi-platform MLPE devices, which means that we not only do microinverters, but also rapid shutdown devices. And we're shortly going to be making our entree into energy storage. So I'll have a little sneak preview for you on that. APsystems has over 3.5 gigawatts installed worldwide, well over 2 million microinverters. Our systems are connected to more than 10 million solar modules. So globally, that's a lot of devices installed all over the world. They serve customers in over 100 countries. On our platform, we're monitoring over 250,000 individual installations, and we're on some third-party financing AVLs, as you see here at the bottom. So just real quick, I wanted to let you know our residential solution. We're going to be talking about commercial, but we do have a residential solution. The DS3 microinverter that we have introduced at the end of last year, it is the most powerful dual module microinverter in the world. And we also have the 3 legs of our architecture here is the DS3 microinverter, the ECU-R gateway. It takes all that information from the production, from the solar panel and the microinverter, and sends that up to our system in the cloud, and that platform is called the EMA. So you see all parts of our architecture there on the screen for residential. And likewise, we have a similar setup for commercial. However, the microinverter is replaced with our new QT2 microinverter, which serves 4 PV modules simultaneously. The ECU-C is our recommended commercial level gateway, and then also the same monitoring capabilities that you would see in the EMA as you would have for residential. So let's talk a little bit about this QT2 microinverter and briefly on that ECU and that EMA portal. So the QT2 stands for quad, or 4 inputs. The T is for 3-phase, and the 2 is the 2nd generation of this product. And there's 2 flavors of it. So we have a 208 volt and a 480 volt. These are you can configure these in Y and Delta configurations. The total output for all four modules is, or for all four channels, would be 1728 on the 208 and 1800 on the 480. So that means it's capable of accommodating PV modules that are 575 watts plus for the 208 version, 600 watts plus for the 480 volt version. Now, the reason that we put that plus at the end is to express that a higher wattage PV module is not going to negatively impact the inverter. So historically, if you say up to 575, someone might think that a 600 watt PV module would be more than the inverter can handle, and that's simply not true. So you want to have that appropriate oversizing for your microinverter. So depending on your preferred AC to DC ratio. It's a true three-phase product. So in the cable, it has 5 wires. So you'll have line 1, 2, and 3, plus your neutral and ground. Phase balanced, phase monitored. It is also UL 1741, now SB compliant, and built-in rapid shutdown compliance as well. And here's our gateway, again, that collects the information, the production information of what the panels are producing and what the conversion information of what the microinverters are producing, and it sends it to our platform in the cloud. And it's also communicating with those microinverters via Zigbee. So it's like industrial Wi-Fi. So we've gone a different path than what some of the conventional systems are doing with power line communication, simply because in today's homes there's so much interference, whether it's an arc fault breaker in a living space or other appliances. We decided to go wireless. And the same for the backhaul. We can do Wi-Fi to connect the gateway to the homeowner's router. But we always recommend an Ethernet cable. It's more reliable. It's also cellular capable, in case you need that. The main difference with our ECUC is that it allows for consumption monitoring. It also has additional inputs, outputs, and relays, zero export function, other features that you might need in a commercial installation. And our EMA is where you would see all of that information that's collected, where you can view this not just on your personal computer, but on your smartphone. So there's a part of the platform that's for system owners and another login type for installers. Different levels of information and capability for each of those levels. So I wanted to show some of those installer features. So being able to have access to all of the module level data, all of the production information. You can also view the curves on current and voltage, etc. Also troubleshooting tools. You would be able to determine whether or not you have a disconnected cable, or the problem is a bad panel or a communication issue. You can assess that before you're rolling any kind of truck to the site. You are armed with what the problem is and where the problem is. And then you also have all those tools at your fingertips with our EMA Manager app. So all of that EMA functionality is now built into the app, so you have that in the palm of your hand. So it's available on the iOS App Store and the Google Play Store. So you'd be able to see that module level view, that performance over time, and your entire fleet view here if you'd like to check up on all your installations. We also have this stoplight feature that tells you, green is good, yellow, there may be a system or a communication issue, and then red is a serious alert that you need to have prompt attention to. It's really handy to be able to kind of check up on your systems and diagnose quickly. All right, so let's talk about why microinverters in C&I applications in the first place. So microinverters really make sense if any of these following conditions apply. If you have a three-phase rooftop application where you need rapid shutdown compliance. If you have a customer who really wants module level monitoring, you want to increase the energy production over a string inverter system. You want to improve reliability over other solutions. And where microinverters are not just ideal for shading, which is a kind of traditional concept, but also in conditions where there's dust and dirt or cloudy days, lots of rain, snow, etc. You have roofs with varying angles, or the system may grow in the future. Another consideration is also if you want to simplify and speed up the installation time on the site. And we'll go into details on each of these. So historically, microinverters did not make sense in commercial industrial applications. Why is that? Well, first and foremost on this list is because microinverters are too expensive. So when you would compare the string inverter cost with a microinverter cost, quite often it was twice the price for a microinverter, sometimes more. And what we've seen over time is that microinverters, because of economies of scale and widespread adoption, microinverters have gone down in price. We've also seen that with rooftop applications, due to NEC code, you now have to add a rapid shutdown system to make those systems compliant. And rapid shutdown systems can add as much as 70%. Actually, the last one I saw was 77% of the string inverter price onto the system. So when we pencil those out now, microinverters are becoming competitive. So even on a 1 megawatt scale project, we are plus or minus 1 to 3% on those systems. So why else were microinverters not really used in commercial? They were too low power, and it was a hassle to wire the systems into three-phase. We've changed that with the QT2 entirely. So the low power is now high power, so we can accommodate these higher power PV modules up to 600 watts on the 480. Again, you can go higher than that if you want, depending on your preferred AC to DC ratio. This is assuming a 1.25. We've seen some use 1.4, even 1.5. So depending on what you prefer for that ratio. And also the wiring into three phases. So here is your traditional microinverter. It's a single phase microinverter. If you wanted to use that on a commercial rooftop application, then you would have to build out on each circuit. That would become, each circuit would become one leg of your three phase. So you'd have, leg 1, leg 2, and sorry, let me use the indicator here. So your leg 1, your leg 2, and your leg 3, and then that would go into a sub panel, and then you would send that out here, put it into a 3-pole breaker on your service panel. So you're manually balancing each leg of the phase with a single phase microinverter. And what we've done with the QT2 is we've built a 3-phase product, and the cable has all 5 wires coming in, going right to your service panel. So we've tried to make plug and play 3-phase to really simplify that entire installation. So it goes in much faster, much more reliable, fewer connections, less headaches, easier wiring, greatly simplifies the whole process. Next, microinverters were historically much longer to install. And they represented more potential points of failure. So on your typical, let's say it's a 100 PV module system, you would have one microinverter for each panel with a traditional system. So you would have 100 potential points of inverter failure. And likewise, with whether it's a string inverter, where each of these is a rapid shutdown device connected to each PV module, or it's a string inverter plus optimizers that are placed with each PV module. In both of those scenarios, you'd have 100 devices that are connected to the panels, and you would have 1 to 4 inverter parts, which would equate to 101 to 104 potential points of failure. Now with the APsystems QT2, you simply have 1 for every 4 PV modules. So you have 25 potential points of failure, or in other words, 75% fewer potential points of failure on your rooftop. Also, think of the simplified installation process. Instead of 1 device for every panel, 1 for every 4. So you're cutting that installation time down significantly. And then also at the end of that, you don't have string inverters to hang and commission at the end. So another myth is that microinverters were only needed for shading. And I would argue that shading comes in many forms. So we've seen some that have been pretty soiled or have a lot of dust or dirt, especially when you're closer to kind of agricultural installations. And I think with microinverters overall, in any of these conditions, they produce more energy over the life of the system, even under these conditions, compared with string inverter systems. So another thing I wanted to share too is that we have a partner in energy with Yada Energy. So Yada does commercial energy storage, and their system is designed similarly to ours as a plug-and-play commercial energy storage solution. So their systems come in 3-phase, so 208 or 480-volt options. They also have pretty much limitless scalability with their system. So you can put one of their solar leaf devices, it's a 1 kW, 1 kilowatt hour battery system behind each PV module. So if you have 100 PV modules, you could scale it up to 100 of those devices. So it's got a pretty significant scalability in 1 kilowatt hour increments. So you can tailor that to exactly what the solution is looking for, instead of having to oversize it, worrying you're going to undersize it, etc. Not only that, but you can also add to this system in the future because it's of its plug and play design. Another great thing is that you don't have to do any kind of construction. You don't have to find a place to put a variety of string inverters, a storage closet. You don't have to pour a pad because it's all placed on the roof. And it also replaces the concrete ballast. So that's another benefit, is you're just replacing something that's already going to be there. And you can also pull that concrete block off of your bill of materials. So the design architecture is the PV module would plug into this device, and then the solar leaf would then plug into the microinverter, so that it's charging with solar throughout the day, and then any excess, once the battery is charged, gets fed to the microinverter for energy conversion. So yeah, that website, if you're interested in, it's yadaenergy.com. And also, as I promised, just a quick sneak preview here for our DS3 microinverter connected with our AP storage solution. So we have our ELS, which is a battery charger intended to charge your backup battery for your house. Couple of great things about this is we're planning on releasing a 5K and an 11K device that is used to charge your battery, which can be our AP battery, but we're also battery agnostic. So if you have a preferred battery, such as a home grid or a Fortress or some other tested and compatible battery, then we can absolutely do that too. So, and then the rest of the similar architecture with our ECUR gateway and our EMA, and that completes the entire residential ecosystem for APsystems. So that's our presentation for today. I'd like to open it up to your questions.
Yep, like Jason said, you can continue to submit your questions into that Q&A box there. All right, so Jason, are there third-party independent lab testing reports available on the QT2?
That's a great question. So I know one of the first things that commercial installers are looking for is a proven and reliable product. So we currently have, because the QT2 is a new product, we currently have it under test with RETC Labs. So those lab reports are going to be coming soon. We do have our previous generation test reports for our three-phase microinverter. And so those are currently available. And if you contact us, we'll make sure that we provide you with the updated reports when those are available as well.
Thank you. Next question, what kind of overcurrent protection is recommended in the output of the inverter, or the fuses or circuit breakers?
That's a pretty good technical question. We have Chris Ling on our team, who's our engineer that's managing that product. I'd be happy to have him follow up with whoever provided that question.
All right, next question. Will the residential storage be compatible with SPAN panels?
So it is an AC coupled system. So it really depends on what the requirements are for the SPAN panels. I'm not too familiar with that one. I'm assuming that might be is that a single phase panel. And yeah, that it should be compatible, but again, we can have Chris Link follow up with that individual as well, just to make sure that whatever compatibility that they're looking for, that we can verify that.
All right, next question. Do the microinverters connect to each other or to a trunk AC line?
Oh, it's a great question. Yeah, we had at one point a system that did a daisy chain, but this one connects to a trunk bus cable. So that's that 5-wire cable. So each of them would connect into that cable, and then that cable goes all the way to the breaker panel.
Thank you. This next person is wondering how APsystems is associated with Yada, as they have their own microinverters too.
Correct. Yeah. So that the APsystems, the Yada microinverter is actually the APsystems system that we have produced specifically for them to pair with their solar leaf. So we've, in tandem with them, we've designed that product to work just how they want it to work.
Thank you. Next question, how many microinverters can connect to the trunk AC cable?
That's a great question. So one of the resources that we have available, if you can look under where the resources are in this webinar, there should be a data sheet. And in that data sheet, we have the information on the QT2, both the 208 version and the 480. And I believe that the 480 volt version connects to 11 of them can go on one trunk cable. So that would be 44 PV modules on one, and it's a 10 gauge cable. So you'd put that on a 30 amp breaker. For the 208, it's 5 units per branch. So that would be a total of 20 PV modules for 208. Again, same size cable, same exact cable that you would put on a 30 amp breaker. So for both, I should also mention for both of those models, it's all the same accessories. So the same gateway, same cables, same caps, same everything. So it makes it very convenient.
Thank you. Next question. Someone's wondering if you have a case study discussing the economic comparison of these microinverters versus string inverters for C&I projects.
Yeah, so we do. So also available in the resources and also on the APsystems website is a case study that we had put together, or a it's called the case for microinverters in C&I solar, and yeah, it explains some of these things in more detail that I'm providing in this PowerPoint. I definitely encourage you to check that out. It's got some great information and resources, and a little bit more information on YADA in there as well.
Thank you. Next question. Please explain the module pairing for a 600 watt PV module on a 450 watt inverter channel output.
Right. So yeah, for some that are new to solar, sometimes looking at, okay, I have 450 watts output from the inverter. How is that going to pair with a 600 watt PV module? So, but that all comes down to three different factors. So with the PV module sizing, if it says it's a 600 watt PV module, it's not actually 600 watts. So that's your STC rating. So it's a laboratory test condition rating where the irradiance is perfect, the angle is perfect, everything is in temperature, everything is perfect, and that's how the module performs. And you're never going to see that in the real world. So that's what the PTC rating is, and you can find that on the CEC website, where they have the PV modules listed there. So the PTC has its own column. So if it's a 600 watt PV module, you might actually get 550 out of that. So you're accounting for that. Also, you're going to have degradation in the panel over time. So you might get the 550 on the first year, but then what does year 24 look like? So you have typically a 25-year warranty on these systems. Also, you want the oversizing to grab the shoulders of the curve. And I've got a little bit. We do a little sunspot video every so often to explain things like that. So on our YouTube channel, youtube.com/APsystemsSolar. We have a sunspot on that explaining clipping and oversizing, and encourage you to check that out.
All right, thank you. If you want hardwired communications, do you need to connect Ethernet to every microinverter? Are those daisy chained?
That's a great question. So actually, I might have a slide that helps to explain the communication architecture. So let's check that out. So in our communication architecture, we have each PV module is connected to the microinverter obviously through the MC4 through the cables, and the production there from the rooftop is then sent via Zigbee. Think of that as industrial Wi-Fi to the ECU. Another great thing about Zigbee is this ECU. Typically, like for a residential setting, you would have that placed near the homeowner's router. It doesn't need to communicate with every microinverter on the rooftop. It only needs to communicate with the closest one, because then they all talk to each other, creates a mesh network to bring that information back to the gateway. So that Zigbee is very helpful. Also, when the NEC code came out to require an arc fault breaker in every living space, we found that it was tough to get a PLC signal through an entire house to reach that router. We have competitors who are still using PLC, and it's a major headache for them and for the installers that are putting these systems in. So we decided to just go wireless with the whole thing. However, when you're doing the backhaul from the ECU to the site owner's router, again, many times these are right next to each other in a homeowner's setting. In a commercial setting, not so. So we always recommend that hardline Ethernet cable, because once the site owner changes their ISP or their router password or any of these a wireless connection may become disrupted. And so it can look like, when I talk about that stoplight system, it could look like the system's down when that communication stops. So we always recommend an Ethernet cable for more reliable communication, because when an Ethernet cable is connected, your router assumes it's a trusted device. And so even if you change an ISP or you change a password, it's going to continue working. Hope that answers the question.
All right, next question. Can the ECU-C be used with the DS3?
Yes. However, the consumption monitoring, it's only designed for three-phase. So that's the primary feature difference between the ECUR and the ECU-C, is that consumption monitoring. So you may as well go with the ECUR for the residential, just because that consumption monitoring feature it would not work for the single phase installation.
Thank you. Next question, is your inverter able to work with generators?
Yeah, as long as they are separate systems, as we would, they wouldn't necessarily communicate with each other, just because the generator and the microinverter, they weren't designed together necessarily. But for example, one of the features that we plan on having on our future ELS design, the battery charger design, is to have a generator hookup to that device. So that way, that kind of adds to the backup capability of that system.
Thank you. Next question, what is the difference between the QT2 and the 5-wire inverter? Is the neutral needed for the grid, and do you need a separate ground fault interrupter breaker?
Yeah, so the QT2 is designed around that 5-wire. So when we first released the QT2, we had a 3-wire system. We thought it would be simpler. But we had some AHJs that prefer the ground in the cable. And it's not all over the country, but we saw it. And we just thought, to simplify the entire installation, we put all 5 wires in the cable for the QT2. So the neutral isn't necessary, and the grounding is built in. So you shouldn't need any extra equipment. You should just be able to connect that to your breaker box and ground it appropriately.
Thank you. Next question, what batteries are you recommending to complement APsystems on commercial installs?
So that's the Yada system is what we recommend. So their Solar Leaf is a 1 kilowatt-hour battery. So that's currently our recommended solution, is to reach out to Yada, and that way you get the best of both worlds. You get the Yada battery technology, module level scalable energy storage, and you get the APsystems QT2 microinverter in the form of the Yada DPI, is what they named it.
Awesome. All right, those were all of the questions that we have time for today. If you have additional questions, go ahead.
I said they're great questions. Thanks, everyone.
Yeah, if anyone has any questions they did not ask, please feel free to reach out and ask Jason on your own. This webinar will be shared with all registrants, so you can view it again at your convenience. I'd like to thank Jason for being here and APsystems for sponsoring today's webinar. And thank you to everyone in our audience for participating. I hope you enjoyed our presentation, and we invite you to join us for more Solar Power World webinars in the future. Thanks, everyone.
Thanks, everyone. Thank you.